In this video, we're going to look at some of the factors that actually affect solubility. And to really understand this, we have to realize that dissolving something is really an equilibrium process. So when we first put a solid into a liquid, there is nothing that is dissolved. So the only thing that we can do is dissolve our solid into the water. Then at some rate, we're going to have the solid, or the things that are dissolved, start to recrystallize. So we still have stuff dissolving, but at the same point, your ions can actually recrystallize onto the solid. But eventually, you will get to a point of equilibrium. And remember, at equilibrium, your reaction does not stop. What it means to be at chemical equilibrium is that your two rates that are opposite have the same speed. So at equilibrium, the rate of particles coming off of the solid is equal to the rate of particles going back into the solid. Or dissolution and recrystallization have the same rates. That is what it means to be at equilibrium, right? So let's talk about solubility and our solubility limits. So if you are at equilibrium, that is your rate of dissolving and recrystallization are the same, your solution is saturated. That is, if you add more solute, nothing more is going to dissolve. You have dissolved all that you can dissolve, and this is based on temperature. While if your solution is not saturated, that is, it can take more solute than it is unsaturated. So if I put more salt into my water, for example, it will automatically dissolve because my solution is unsaturated. However, it is possible to put more solute into your solution than what is theoretically possible. And we call this a supersaturated solution. Very unstable, and your solute will fall out very easily, but it is possible to make a supersaturated solution. And so let's take a look at this. So let's say that you are dissolving salt in water, and let's say you heat up your water to 90 degrees centigrade, and then you dissolve your salt in that water to its solubility limit to make a saturated solution. And then you let the solution cool down very slowly, very carefully without without disturbing your solution. And what will happen is that your salt will remain dissolved in the water. They will not fall out of solution. They will not form a crystal, and we call this supersaturated. But this is very unstable, and when anything disturbs the system, then everything will come out of solution. Good example, carbonated beverage, when you shake it, all the gas is going to come out and you get a fizzy drink. And so let's look at a supersaturated solution of salt. Here it is, it's supersaturated. And what's happening is that we're just going to go and add one more drop of salt water to this solution. When you add that salt, you get a spontaneous reaction, and all the salt crystals will come, not all of them, but salt crystals will come out of solution and reform your solid until your solubility limit is reached with this new temperature. So supersaturated is possible, but very unstable. In temperature dependence of solubility, so when we talk about solubility, it's basically how many grams of stuff can we put in 100 grams of water. And it's very temperature dependent, but for each salt, each solute, the way it's dependent on temperature really changes. For example, we have something odd like cesium-2, SO4-3, solubility decreases when we increase temperature. KClO3, solubility increases while we increase temperature. NaCl, solubility more or less stays the same when we increase temperature. So it just depends on what salt you're using. But for the majority of the salts, you can dissolve more stuff at higher temperatures. And that's only if delta H solution is endothermic. And what we're looking at here, they're solubility curves. Basically, how you read these curves. If you try to dissolve more salt than you can be at that temperature, so let's just focus on NaCl at 20 degrees. So at NaCl at 20 degrees, we can dissolve roughly 35 grams of sodium chloride for every 100 grams of water. Now, if we dissolve 40 grams of salt at 20 degrees, our solution is supersaturated. If we dissolve only 30 grams at 20 degrees, we are unsaturated, while we dissolve exactly 35 degrees, we are saturated. So that is what these different lines can tell us. And let's talk about solubility of gases now. And so for gases, they are low solubility in water than your solids. That's because gases, for the most part, are non-polar, and water is polar. And so gases generally don't dissolve in water all that much. So for gases, though, solubility of the gas decreases with temperature increasing. So gases actually are more soluble at low temperatures. That's because delta H solution is exothermic here. So when you mix a gas with water, the gases don't care what they're interacting with. So you don't have to break apart any gas-gas interactions. So delta H solution is exothermic. So the higher it is, the hotter it is, the less likely that gas is going to want to go in that solution. As shown here with your soda, when you pour cold soda, you don't get many gas bubbles. But if you pour warm soda, that gas is going to come out of solution because there's a lot of kinetic energy here kicking out your gas molecules. Right? And now, one last thing we have to talk about is the pressure dependence of solubility for gases in water. So the more pressure, the larger the partial pressure of a gas with your liquid, the more soluble your gas is in that liquid. So higher the pressure of your gas, the more it's hitting the water, and the more likely it is to go into the water. And we have an equation for that. It's called Henry's gas equation, Henry's law for gases here. And the solubility of the gas is equal to Henry's law constant times the partial pressure of the gas. So if you want to find out how soluble your gas is, you need to find out the partial pressure, and then you would look up Henry's law constant from this table. And you just plug in the numbers, and you can find out how much gas should dissolve in your liquid. Right? So that's it for this video. I will see you in the next video.